Good day everybody, we got a beautiful question. We are expected to find the area of the shaded region. We are looking for this area, right? This region. Now we've been given a few important informations. We got DOE is the diameter of the semicircle, and that is given to be as 14 units. Okay, and then we've been given OF is equal to BF. So this side and this side are one and the same. And then we are given GH to be equal to 5 units, and that GA is equal to OG. So these two sides are equal, right? So that would mean we got an isosceles triangles inside this triangle, and we are also given GC. Now GC is given to be as 3 units. So if I were to write these things down, foremost we got DOE, which is 14 units. So 14 units means the radius OE will be 7 units. So this is going to be 7 units. And we are also given BC. The value for BC is 15 units. So this entire length is given to be as 15 units, and then GC is 3 units. This is 3 units, and GH is given to be as 5 units. This is 5 units. Now OG, okay, GA, this is not GH, this is GA. GA is equal to OG, right? And GH is given to be as 5 units. This segment is given to be as 5 units, and we are expected to find this region, the shaded region. Now we see that there is a semicircle and we have the diameter of the semicircle. So I have extracted the radius, and to get the area of the shaded region, area of the shaded region is equal to, now you have a quadrilateral here, right? GCFO is nothing but area of quadrilateral GCFO, right? GCFO minus area of the sector. Area of sector, you got a sector here, OHF. So if you can get this, and from this you subtract this, then the solution can be obtained. So I'm just going to show you how to do that. So having got that, first we need to get this value, right? Now let me take this value as some theta. Okay, now these two angles are one and the same. This angle are one and the same. So that would mean, or I should say, this side and this side are one and the same. So they will have a same base angle. So let me take this they will be making the same base angle. So let me take this as alpha, so this will be alpha, right? So that is fine, we got that base angle. And then these two sides are same, so they will be making the same base angle. So let this be beta and let this be beta, right? Fair enough. So we got these values. Now what we need to do is we need to apply some concepts of basic geometry to obtain the solution. So let's do that. Now if you were to observe here, the line drawn through the center is hitting the tangent. There is a tangent at F, right? So solution, I'm giving the solution here. We see that the semicircle has a tangent at F. Semicircle is having a tangent at F. So this would mean a line drawn through the center will make an angle of 90 degree with the tangent. This is by theorem at F. So this is going to be 90 degrees, right? Now consider triangle OBF or OFB. So clearly the sum of the angles alpha plus 90 will be equal to 180. So this would mean 2 times alpha is equal to 180 negative 90, which means 2 alpha is equal to 90. So alpha is equal to 45 degrees. So I've got alpha is 45. So this is known, 45 degrees. Now if I were to consider this entire triangle, now consider triangle ACB. We see that, what do we see? Alpha plus beta plus this is 90 is equal to 180. So alpha plus beta is 180 negative 90, which means alpha plus beta is equal to 90. So alpha is 45. So 45 plus beta is equal to 90. So beta is equal to 90 minus 45. Therefore beta is 45 degrees. So we got the value of beta, right? Now you consider this region. What is this? This entire angle, this sum, right, will be what? Also we know that beta plus theta plus alpha, this entire angle is going to be equal to 180. We know beta is 45, alpha is theta, alpha is 45, you got the theta there, you got 180, this is going to be 90. So theta is 180 negative 90, which means the angle theta is making an angle of 90 degrees. So there is a 90 degree angle there. Okay, so we have got the value of theta. Theta is obtained. Now why did we need that value of theta? Because we want to find the area of the sector, right? And it becomes important for us to get the value of the area of the sector. So we need to use the formula, right? So what is the formula? Area of sector is equal to theta divided by 360 multiplied by pi r squared. Theta is 90 and you got 360 multiplied by pi times the radius. Diameter is 14 units, radius is 7 units. So 7 squared, 0 0 cancel, this will be 4. So you got pi times 7 squared is 49, right? So 49 divided by pi square units, right? I'm not going to do anything as of now, so let it be as it is. 49 pi divided by 4 square units. Now you have an angle of theta here, you have an angle of 90 degree here, and you got an angle of 90 degree. Two opposite angles are known, right? Now this total length, this is 7 units, this total side GO. Now GO is 5 positive 7. This side is 7 units, is a radius, right? From the center drawn to the circle. So this plus this, so GO is 12 units. You got this side. Now you have this side GC, right? GC is 3 units. Now this entire side is 15 units, but the radius OF is hitting the tangent at this particular point, and we are given that OF and FB are one and the same, right? OF and FB are one and the same. So that means this is 7 units. So this is going to be 7 units. This entire length is 15 units, but I need only this length, CF. So CF is going to be 15 minus 7. That's going to be 8 units. And this side, OF is equal to 7 units. So I've got 4 sides of the quadrilateral, and I've got the opposite angles, 90 degree, 90 degree. Right? Now what we have to now do is we got to find the area of the quadrilateral. So what I'm going to do, I'm going to find the area of the quadrilateral as I mentioned here. Then from the area of the quadrilateral, I'm going to be taking away the area of the sector. That's a point. Now how do we get the area of the quadrilateral? I'm going to be utilizing what is called the all important formula. So let me write the formula down here for you. It's called as Schneider. Okay, formula, Schneider's formula. Now what is the formula? The required area is equal to root of S into S negative A, S negative B times S negative C times S negative D, multiplied, I should say followed by a negative sign, and ABCD times cos squared of the two angles. You can take it as theta 1 plus theta 2 divided by 2. Right? This is the formula. Now draw the square root. Now we know theta 1 plus theta 2. Now theta 1 plus theta 2, both of them are 90 degrees, so we need to take in these opposite angles, this angle, this angle. So that's going to be 180 degrees. 90 plus 90 is 180 divided by 2. 180 divided by 2 is 90. So you got cos squared of 90 degree. Now if you don't get 90 degree, if you get some other angle, then there is a different way to solve this question, different way to solve this, but in this case it's too simple. Cos squared of 90 is nothing but cos of 90 raised to the power of 2. Cos 90, what is cos 90? 0. This is going to get 0. So this term vanishes completely. So all we got is root of S into S negative A, S negative B, S negative C, S negative D, where S is equal to A plus B plus C plus D divided by 2, where place in the sides 12 plus 3 plus 8 plus 7 divided by 2. This is 15 units. This is 15 units divided by 2. So 30 divided by 2 is equal to 15. So perimeter is 15 units. So 15 of 15 negative 12, 15 negative 3, 15 negative 8 and 15 negative 7. So this is equal to square. Oh, there is one small correction. You don't have a S here, right? In the Bruch-Schneider's formula, we don't have a S here, right? So it becomes too much simple. So S is removed. S is not there. Please make an observation. So 15 negative 12, that's going to be 3, this is going to be 12, this is going to be 7, this is going to be 8. Now this is equal to root of, this is 7 times 8 is 56, 56 multiplied with 3, 6 3s are 18, 1, 15, 16, 168 multiplied by 12, 8 times 2 is 16, 1, 12, 13, 1, 2 ones are 2, 3, 8 ones are 8, 6 ones are 6, 1 ones are 1, 6, 11, 10 and 1 there, 2, right? So I need to take the square root of 2016. So let me use my calculator and give you the value. So the value of this is approximately 44.90. This is the value for the area of the quadrilateral. Now as I mentioned to you, we also need to calculate this value. So let me also get that value down. You can actually use your calculator here. So I'm going to take 3.14 multiplied by 49. I get 153.86. You divide by 4, you get 38. This is going to be 38.465. Fine, fantastic. So from this, I hope you're able to see, from this value, required area is 44.90 minus 38.465. So we need to get that value. So let me get that down. 44.90 minus 38.465. Right, so this is approximately equal to 6.435 square units. So let me write that down here. Required area is 6.435 square units. This is an approximate value, right? So this is a beautiful question. Why is it so beautiful? Because you need to first get the value of theta actually you need to use the concept of isosceles and then get the value of theta and then use the Brodch-Schneidner formula to get the area of the quadrilateral. Then from the area of the quadrilateral you subtract the area of the sector and then that would lead you to the required area. Thank you everybody.